Tickets for a school play cost $8 for adults and $5 for students. Feel free to underline what you feel like is important. The auditorium in which the play is being held can hold at most 525 people. And the organizers of the school play must make at least $3,000 to cover the cost of set construction, costumes, and programs. So must make at least $3,000. We are writing a system of inequalities. So that means that there will not be any equal signs. Okay. There might be 2, there might be 3, just so you know. Let's think about the first 2 numbers here. This is about cost, right? $8 for adults, $5 for students. Which other number goes with cost? 3,000. So we want $8 for adults, $5 for students. If you want to make, looks like we've got adult is X, that's already labeled on there. And student is Y. So I'm just going to label that so I know. And this is about a school play, so I'll give that a title. School play. Okay, $8 for adults, X. Plus, what should I put next? 5. Y. $5 for each student. And that has to be, it's not equals, it says at least $3,000. Okay. If it's at least 3,000, can it be, do we want it to be less than 3,000? No. Do we want it to be greater than 3,000? Greater than, can it be equal to? Yes, so at least is going to be greater than or equal to. Okay, we need another one because we've got another number here. At most, 525 people can fit in that auditorium. You don't have any other 2 numbers to go with it. Do you guys remember what we do in that case, Trinity?
Would it be Y is less than or equal to 525?
No. We're going to use less than or equal to. I like that. But it's got to include both variables. I don't remember what we do. We have X plus Y. We have a total of 525 people, so it's X plus Y, the people together, because X stood for students, or X stood for adults, Y stood for students, and that has to be at most 525. Can we have more than 525? No, at most. I mean maximum of 525, so it has to be less than or equal to. You can't have anything more than 525, or who knows what will happen to the auditorium. Okay, those are your 2 inequalities. I don't see any other numbers we need to use. We should be good. Now we need to graph it. As we discussed yesterday, if you have something that's in standard form, you need to move it into slope-intercept form. So for both of these, we need to get them to be y equals mx plus b, except not equals, so it'll have an inequality. So let's take each one, and we're going to solve it. I'll do this one in red. So 8x plus 5y is greater than or equal to 3,000. Let me see, what do I do first?
Subtract it.
Okay. And then we are left with 5y is greater than or equal to 3,000 minus 8x. Emily, how do I get rid of the 5? Divide that because it's being multiplied. 3,000 can divide evenly by 5. Anybody got it?
600.
Thank you. 600. And then that 8/5 you can leave as 8/5. Or you could put it as a decimal since this is real life. What is 8/5 as a decimal? 1 and something. Can someone figure out, please, what it is? 1 1.6, okay. 1 1/10, so 1.6x. So again, it's okay, since these are real life situations, if you want to go ahead and put it as a decimal, like try both ways, that might be more helpful. Sometimes you'll be able to do fractions and that'll work out nicely for you, but other times it might just be easier to get the decimal. Okay, rearrange the other one as well, x plus y less than or equal to 525.
How do you know when it's better to use the decimal? Or
Depends on how many squares you got on your grid. So on the one we have today, it will not be able to go down 8 and over 5 because you'll run out of room. So it wouldn't fit. So all we got to do is subtract the x, and it should be in slope-intercept form. 525 minus x, so that one has a slope of -1. You're going to graph both of these. Let's start with the easy one. Start with 525 minus x. My slope is -1. So we are going to start, I'll do this in blue. Start at 525, which, right, you know halfway is 550, so you want to go about the fourth of the way up. Right there. And you need to go down 1, over 1, down 1, over 1, down 1, over 1. Another trick, something like this, we should end up hitting 525 at the bottom because we're just going down 1 over 1. So let's go and do that. 5 down 1 over 1, over and over, and when you connect the line, you should hit 525 because that, if you solve for the x-intercept, that's what you'd get. Because it has a slope of 1, it should hit at 525 on the x-axis. And if you want to go ahead and lightly shade that one, it is less than or equal to, so should I shade below or above? Below. Do it this way. But if you're going to shade it lightly. Now we have to do the other one, which starts at 600. So 600 is my y-intercept. And then it goes down 1.6 and over 1. So you can make that into a fraction to help you out to figure out the slope. So you're going to have to go down 1.6 squares over 1 square. So you have to, so it's about 1.5 squares is how much you're going down. A little bit more than that, think of that to help you. So 600. Go a little bit more than 1.5 squares down and go over 1. So about there. Go a little bit more than 1.5 squares down and go over 1. And you keep following that all the way down. It should hit the x-axis at 375, and I'll show you why I know that in a second. But you could just use your slope, go down about 1.5 and over 1, over and over until you hit the bottom. And this one is shaded, it's greater than or equal to, so you will shade above it. So I hope that you see where these overlap. Is right here. I'll do this in solid. It's that cute little section right there. That is your actual solution area. So a possible combination of tickets that would actually work. Could someone give me one combination that would work? Has to be in this solution area. I see a couple points. 400 and 100. 400 adult tickets, 100 student tickets. That's in the black area, so that works. You could do, and any of the points in here work. I know it's hard to pick out some that work perfectly. 300 and 200 would work. So as long as a point is in that black shaded area, that works. I'm going to show you one more thing. I don't need you to write this down, but just so you can see, if you're having trouble graphing it because there's a decimal or something, then you could find the x-intercept. So if I wanted to find the x-intercept for 8x plus 5y greater than or equal to 3,000, like we know that the y-intercept was 600. The x-intercept, remember we just plug in 0 for y. And those cancel out because 5 times 0 is 0. So if you divide by 8, then you get the x-intercept to be exactly 375. So instead of graphing all those points along the way, you could just graph the y-intercept and the x-intercept and be done with it. So if you prefer that, that works. All right, let's move on. I want you to go ahead and read through this and underline what's important, please. You want to build a fence for a rectangular dog run. You want the run, and a dog run is just like kind of like a dog park, okay? You want the run to be at least 10 feet wide. That's probably important. The run can be at most 50 feet long. You have a total of 126 feet of fencing. In case you're having a hard time visualizing this, this is a rectangle with width and length. Let's go ahead and say, just to make it easy on ourselves, let's use x and y. Since we're graphing x is, let's make that the width, and let's make y the length. So my little rectangle over here, I should label my width as x and my length as y. So there's two x's, the widths, and there's two y's for the lengths. So we have to build a fence all the way around. That would be the perimeter. Okay, let's write some inequalities. You're actually going to have 3 inequalities for this one. Okay, you want the run to be at least 10 feet wide. And we have an idea for what I should write. The run has to be at least, which means it could be more. We want it to be at least 10 feet wide. What should I write for that inequality? The run width.
Just like the x. Does it just say x?
X is what? Can x be greater than 10 feet?
Yes.
At least, yes? And it also could be equal. X has to be greater than or equal to 10 feet. The width. That's it. Doesn't have to have an x and a y. So let's see if you can get the next one now. The run has to be at most 50 feet long.
Does that mean less than?
Haley, what would the next one be?
Y is less than or equal to 50.
Right. And then the last one is you have a total of 126 feet of fencing.
X plus y.
Yep. Total, add them up, set it equal to 126. X plus y says you have a total of 126 feet of fencing. Can you use more than 126? So this is another one that's less than or equal to 126. Oh, we messed up. Hold on a second. Fencing goes all the way around the outside, right? How many widths do you have in a fence? 2. And how many lengths? So it's actually 2x plus 2y. You're close. It's not just width plus length, it's 2 widths plus 2 lengths has to be less than or equal to 126. So add in some 2's. The first 2 you should be able to graph right away. The last one you need to get into slope-intercept form. So we need to solve that equation, that inequality for y. If you feel good about that, go ahead and do it. Move your x term by subtracting it. And then divide by what's in front of y. So that would be y is less than or equal to 63 minus 1x. So you have 1, 2, 3 inequalities that you have to graph. Oh, hello. Also, you should notice that the scale, nothing has been written on the axes, which means that you have to do it. You know what? We said what x stands for. What's it stand for? Width. And how are we measuring width? How are we measuring things in this problem? Feet. So x, label it width in feet. And then y, we are going to label length in feet. Hopefully neater than I did it. Struggling. Okay. I'm going to try one more time. I'm going to give it. That's mildly better. Okay. We know that the x has to at least go up to 10, probably farther than that. The y has to go up to at least 50. But then this last one, the y-intercept is 63, and it's going to go down 1 over 1. So where is it going to hit on the bottom? If it goes down over 1 every single time, it's going to start at 63 on the y. Where will it hit on the x? 63. So we know that both of the axes actually have to go up to at least 63. This is real life, so you only want the positive quadrant. So if you drew in any other axes, erase them. We need it to go up at least to 60. You can use trial and error. You could skip 2's. I'm going to skip by 3's. And go 0. If you want to do more, that's fine. So if yours is a little bit different, that's fine, as long as it goes up to at least 63. So I'm skipping 3 squares and labeling another 10. $50, $60. So that'll give me plenty of room. And then same thing on the bottom, because it's got to go to 63 over there as well. Mess that up. Screwed up. This one? I had that too close. Okay, so now we just graph. We're going to graph x is greater than or equal to 10. That would be a vertical line. That's, which way do I shade that? Right, greater than or equal to 10. Going to have the length, it's y is less than or equal to 50. So a horizontal line at 50. And shade below that, lightly, if you're doing this, because we're just trying to see where they overlap so we can give our final answer. And then the last one starts at 63. So 63, each of these squares is Since I skipped 3 squares, each of these squares is worth about 3.33. So we're going to start right above that line. It's going to go down 1 over 1, down 1 over 1. Where's it going to hit on the bottom? 63. But if you want to use a slope, that's fine too. You'll get the same thing. You could just put a bunch of little points along the way. You'll end up there. Connect them. Y is less than or equal to, so shade below. And there's actually a pretty large area where these all overlap. It's all of this. Okay. So lots and lots of options for this one. I want you to list for me one possible combination. Of length and width. So write one possible combination of width and length down that would actually work. Based on where you see the overlapping region, what are possible lengths and widths of this dog run? Kirsten, what's one of them? Okay, so width of 30 and a length of 10. That's one possible combination. Anybody got something different? There's lots of options. Anything in that shade region. Lillian, can you give me one?
I said 30, 10.
Okay, you got a different one?
30, 20.
Okay. Width of 30, length of 20. There are so many options. Any point that you can find that's in this black part works. Okay. Word problems. Good stuff.